All right, here we go. What did we get through yesterday? Just G? Okay. So, H, again, so yesterday we learned indefinite integrals, and today we're just practicing definite integrals. So we're just going to do 3 problems, and you have your assignment. That's it. A lot of time to work. I use the fundamental theorem of calculus part 2 for this problem. I have to find the antiderivative of 4y, which is this is 3y to the negative 2. If I find the antiderivative, so plus 3 over y, okay. Now I plug in negative 1, 2, minus 3. I'll take that quantity minus what? 18 minus 1. So I have negative 1 minus 17 is negative 18. Yeah, Kimball says pretty easy. I would agree. I just want you guys to understand that as you look at this, that's an interesting shape. Is this shape ever undefined? Yes, it's undefined at 0. Do your boundaries go over 0? No, so therefore we can apply the fundamental theorem. But even just making that statement that the area bounded between negative 3 and negative 1 of 4y minus 3 over y squared in the x-axis, and we found it to be exactly negative 18 that quickly. That's impressive. All right, let's try 2 that are a little bit more challenging. Good thought, but incorrect. If it was a 1 minus sine squared, I could write as cosine squared, but this is 1 plus sine squared. Bo sees it. Anytime that you can divide through by the denominator, that might be a good option. So I'm going to write this as 0 to pi over 4 of 1 over sine squared of theta plus 1. I just divided each one by sine squared. Right? What is 1 over sine squared? Cosecant squared. So we have the integral from 0 to pi over 4 of cosecant squared of theta plus 1 d theta. Do you know what the antiderivative of cosecant squared is? What? Negative cotangent. The derivative of cotangent is negative cosecant squared. So the derivative of antiderivative of cosecant squared, negative cotangent. What is the antiderivative of 1? No, just cotangent. So I don't have a cotangent button on my calculator, but I do have a tangent button. What's the tangent of pi over 4? 1. So the reciprocal of 1 is 1. You make it negative, so negative 1. Then we plug in 0. What's the tangent of 0? 0. So cotangent of 0 would be undefined. If you have anything that comes up as undefined, we would say the whole expression is undefined. We do not know what it is. And we could tell, well, we have a way of dealing with these type of integrals later on in calculus too. But for right now, as you look at this, that 0, what is the sign of 0? 0. So you end up with 0 in the denominator from the beginning. So you could tell right away that the fundamental theorem of calculus part 2 does not apply in this scenario. It must be bounded across AB. So I wanted to work it out for you so you could see the trick to the trigonometry. The only issue is, let's say this would have been from 0.1 to pi over 4, we would have been fine. But in this situation, doesn't work. Okay? All right, so our last example. Pi over 3, pi over 6 to pi over 3 cotangent sine. Yes. Good. So now we need to evaluate sine of pi over 3. Let's try to do this exact. Let's bring back your trigonometry. There's a lot of trig here, and I, yeah, this is a 60-degree angle, right? So sine of a 60-degree angle, sine is going to be the y value, correct? I mean, you remember making those shapes, right? So our coordinate is 1/2 root of 3 over 2. So sine is y over r, in this case just the y value, so you got square root of 3 over 2. Minus pi over 6 would be a 30-degree angle. So you've got, this is 1, this is 1/2, this is root of 3 over 2. So root of 3 over 2 and 1/2, sine is the y value, so 1/2. So you get root of 3 minus 1 over 2 is the exact answer. Now, yeah, on the AP Calculus exam, that's what they'd want. And I know I can even point to the assignment where we had 24 problems last year where we found the exact values of these expressions. So you should, it all just comes back to just being able to sketch the right triangle. And this, 60, 30, 60, 90 piece, that's a geometry skill that you learned as well. So I would like it in this form. I really would. Okay. So where does that leave us right now? Today, be very clear about this. I'll hand out your assignment to you where you're going to do 1 through 14. Warning, 3 and 4 are tough. And when I say tough, what I mean is this. You should be wrestling through this. I would be more than happy to help you, but I don't want to help you after you've looked at it for a minute and a half. I want you to give it some time. Okay? And and why is it tough? It's not tough because of the calculus. It's tough because of the algebra. You can see that we involve some trigonometry here, 17 through 38. They're not easy. This should not be an easy assignment. You've got a lot of practice problems. We have 2 sections to get through for this test, 5-4 and 5-5. That's it. And so this will be the majority of your practice. I will not be here on Monday. You will have an extension assignment off of this. It'll be about 8, 12 problems on a worksheet that I will give to you. Yes. I don't think we'll get to this by next week, Friday. I don't think we'll get to a test for next week, Friday. The following week, we would have a test. No. Yeah. So, everybody okay with that? All right, I'll get you your stuff.